Morning, it's Sunday, October the 1st, 2017. We're here at the airport. I got a couple of things I'd like to go over today. I'm not going to go flying. I got too many things to do this afternoon. I can't take the time out. But I did come down and check on the plane, and while I was here, I thought I would. I've been asked a number of times to talk about the panel and kind of just walk through and show how the panel is set up and what each gauge and dial is. I've been asked 3 or 4 times for that. And I also wanted to share with you this website I found, and I have no affiliation with it. I'm not sponsored by them, or I didn't know them until I got this thing on eBay. It's called Flyboytoys.com, and they are like a specialty graphic shop. I don't know what else to call them. So what they do is you'll send them a picture of your plane or a car or something that you're interested in. It could be a boat, I suppose, and they'll put that on hats and mugs and I bought a pullover sweatshirt, and let me show you here. This is the mug. Let me switch the camera here. This is one of the mugs I ordered. It's an insulated mug. And they were able to take and put the plane on the mug with the N number and everything. I thought it was just the silliest thing, but it was kind of cool. I also got a hat. Let me put that down here. And they put the Piper Comanche, and then they put the N number on the back. And I just thought it was kind of the silliest thing in the world to have. I also bought a sweatshirt. Anyway, it's called Flyboytoys. They do all kinds of stuff. You can go out to their website and look. I just thought it was funny. Okay, so let's go over the panel here, and we'll start that. Sorry about my camera work. I'm sure my wife will make fun of me about it. Okay. All right. So get down in here. And what I was asked to do, Comanches come with a lot of different panel configurations that over the years people have added on and done different things. 6928 Papa has what's called a Ron and John's panel, so it's a modernized panel. Before it had a shotgun panel where basically these gauges were here in the middle, and they might not have been arranged in this fashion, but they were over here. And I guess the thought being that the pilot and co-pilot could share them that way. And then the radios were down here. What the Ron and John panel done is make it a more modern. You got the conventional 6-pack layout, and move the radio stack over here to the center of the aircraft. And now I'll just walk through each gauge, how I got it set up, and tell you a little bit about it. For those folks that have a Comanche that are looking at doing this, it's a great upgrade, I think, as it makes the airplane just simply look more modern. And I think you get a little bit more radio room with the radios over here than you do with them over here. So let's start out with the yoke. So I use just a RAM pad RAM mount for the iPad, and it's on a C-clamp type setup here, or a hose clamp. And you can see I run mine up and underneath the yoke on one of these long bars. That way it's tilted back here for the iPad. And I've run this on Cessnas. I've run this setup on the Comanche, and in a Cherokee I was flying. So if we start here in the upper left-hand panel, or upper left-hand corner, well, actually let's start over here. So outside air temperature gauge, pretty straightforward. I like the position of that because it's easy to check for ice. If you're going through clouds and the temperatures are questionable, that little things sticking out in the airstream will pick up ice faster than the wings will, and it gives you some warning. So I like having it that close. In the upper, here, let me turn on the master switch, and we'll just bring the radios and everything online. So in the upper left-hand corner, this is the ship's clock, and it's a chronometer, so it does time, it does stopwatch, and I think it'll do a countdown on elapsed time as well, or something like that. Mainly what I use it for is timing my fuel tanks. So my typical fuel plan is I switch tanks every half hour, unless I'm going on a long distance trip, in which case I'll switch them every hour, except the tips. The tips I still do every half hour. They're so far out on the end of the wing there that you take 7 gallons out of that, and with the arm of the wing, it's quite a difference. So I do switch those every half hour, even on long trips. The next one down here is the suction gauge, and that will actually go bye-bye here in the next annual when I replace the vacuum, or I pull the vacuum system out entirely. There'll just be a blank cover there. Up here we have the airspeed indicator, and it does true airspeed calculation as well as indicated airspeed calculation. Some for pilots, for non-pilots actually I should say. What is the difference? So indicated airspeed is really all the wing cares about. And I am going to do a talk or a video on some of my favorite books, and one of them is Stick and Rudder by Wolfgang Longovich, and I'll do a show you that one when I. But anyway, one of the best parts about his writing is he explains what is actually important to the plane, what's important to the pilot in flying, and it's really angle of attack is what it boils down to. So indicated airspeed is what the wing cares about. True airspeed, you need to calculate how fast you're going to get somewhere. Now those two are not the same. Here's your science lesson for today. For non-pilots, you have to understand as you climb up higher into the atmosphere, the air is thinner. Therefore, the plane can go faster through it because there is less drag when there's less air molecules up there. So your indicated airspeed as you climb will actually drop to a certain extent. You're making less horsepower. There's less air pressure through the pitot-static system. But your true airspeed through the air is faster, because until you get to a certain level, and then things start to really slow down because you just don't have enough horsepower. So that's the difference between indicated airspeed and true airspeed. Like I said, we care about indicated airspeed for flying. We care about true airspeed for flight planning, so we can try to figure out how fast we're going to get somewhere. Then you take into account winds and all the rest of that. Okay, right below it here is the turn bank indicator with the slip skid ball, and this is what drives the autopilot in my configuration. It's electrically driven gyroscopic instrument, and then the ball is gravity driven. If the airplane is skidding or slipping into a turn or out of a turn, if it's skidding out of a turn, the ball indicates what it's doing. All right, the next piece up here, and I think I'm going to have to turn off the light on the thing because it's too bright. Give me one sec. Okay, hopefully that's a little bit better. Okay, so I showed this before. This is a Garmin G5. And this instrument is a primary attitude indicator, but it's secondary for airspeed, altitude, and bank angle. Up here you can see it's got a turn and bank indicator down here on the bottom. I don't know how well you can see that. It looks like it's reflecting. And then the ball is between those two lines. So it runs secondary for this instrument, this instrument, this instrument. Now, in this configuration, this February, I'm putting another one of these and replacing the directional gyro. This instrument has an HSI capability that I'll put down here. So down here will be the HSI, and up here will be the same attitude indicator. Okay, these are both be tied in to the Garmin 650, which is this, and we'll go over this in a second. So come next spring, I'll have 2 of these basically in here. Okay, then next over we got the altitude indicator, and that has, hold on, I gotta turn the light back on. Okay, there it's back on. So the altitude indicator, and this has what's a Colesman window, I think is what's that called, and you set the barometric pressure using this knob at each, well, every time you switch controllers, they will give you a new barometric pressure, and if you're not talking to controllers, you should check it every, maybe 50, 100 miles. You just get an ATIS from the nearest airport, and you get on the radio and you listen to that ATIS, and it'll tell you what the barometric pressure is for the field. That way you can keep on the right altitude. Once again, for non-pilots, why is that important? Okay, so there is basically everybody flies at what's called mean sea level. It's not your height above the ground, it's the height above a fictitious, I don't want to call it fictitious because it actually can exist, sea level. So, and this is below 18,000 feet. There's another rule for above 18,000 feet, but we won't go into that because I don't go that high. What does it mean? So all the pilots, every airplane agrees to a standard altitude, and you adjust that standard altitude by adjusting the barometric pressure. So Moline, for example, is like 590 feet. So I know right now that the barometric pressure is somewhere around 30.16-ish in barometric pressure. And as I fly east, I'll be heading into a high pressure system. If I fly west right now, I'd be heading towards a low pressure system. So every once in a while, you'll have to turn this knob to adjust this to the proper altimeter setting to move this needle, and you're talking, well, it can move quite a bit if you were to travel across country, but it moves it a little bit at a time. That way, it's easier for ATC to keep separation in altitude-wise, because all the planes that he's controlling in that altitude or in that area are agreeing to a mean sea level pressure. All right, there's second science lesson for today. All right, this is a rate of climb indicator. So this one will indicate up to 2,000 feet up, 2,000 feet per minute down. Really, I don't see normally over 1,000 because I don't really honk on it that much to get it climbing. But the plane is capable, light is capable of 1,500 feet a minute. As you can see, mine is out of adjustment slightly. That's something that I got to work on at annual. There is an adjustment thing in the back that the mechanic can turn to center that up on 0. This doesn't actually work. This used to be a remote compass. I'm going to have that removed at next annual. It just simply doesn't work. Right now I'm facing almost due east, and as you can see, it's off. Down here, well, here we'll go over the lower side of the panel. Now, this used to be a radio rack. I use it now for my emergency checklist book because it's always there. It's easy to get to. And so we have a small circuit breaker panel that handles the panel lights. And each one of these casts a little light on each gauge, right? And then underneath the edge of the glare shield here, there's a strip of LED lights that kind of cast a light down. I don't fly at night. Actually, I haven't flown at night since I got my private pilot's license. One, because I'm not a night owl. I go to bed at 10 o'clock. I'm asleep by 10:02. So I'm not one for really moving around much at night. Then we have our switches. Here's where my headset plugs in. We have master switch, fuel boost pump, more lights. These are for outside lights, nav lights, and then we have the landing and taxi lights are here. The turn and bank power that turns on this instrument. We got the Rotating beacon switch, off is everything is off. Up turns on the strobes and the rotating beacon. I leave that constantly down so the rotating beacon's on. That way I know the master switch is on if I get out of the aircraft and I see the light flashing. Pitot heat, and then this is the radio stack. This turns on all the avionics. Okay, this is a gear up, gear down switch. Right now gear is down, and I put last annual, I put these, you can close the iris so at night, if I were to fly at night, it's not so bright. And then of course the yellow one is for gear, indicates gear up. The key starts the engine and also turns on the left and right magneto, parking brake, mixture control, throttle, prop control. Now what is a prop control and what is a mixture control? So real quick, in the old days of the automobile, you used to have to adjust the mixture because it was carbureted. And as you went up in altitude, the air gets thinner. Therefore, you got to thin out how much fuel the engine's getting in order to get proper combustion. If you have too much fuel, it doesn't burn right. If you don't have enough fuel, it doesn't burn right. So the mixture control is used as we climb up in altitude to lean out the mixture. And that's the easiest way to put it. Above 5,000 feet, I start leaning, and I watch my EGT and the cylinder head temperature gauge to see how am I doing with that. And I'll go over the cylinder head temperature gauge. Throttle is throttle, just like throttle on your car. Push it in to go fast, pull it out to slow down. And once again, if you read Stick and Rudder, there are other ways that you can speed up and slow down. And he goes into that because you're working in three dimensions for the non-pilots. Okay, propeller control. Once again, for the non-pilots, what does that do? That adjusts the pitch of the blades. So a propeller is an airfoil, same as a wing. And you can change the angle of attack on the propeller blade to go from a high angle of attack to a lower angle of attack, depending on how fast you want to run it, right? So what this does is it angles the propeller blades slightly, and it controls the governor that angles the propeller blades slightly. So when it's full in like this, I have basically a climb prop. In other words, the prop is turning very quickly, high RPMs, and taking little bites of air each time it turns, but it's turning very quickly. You use that for takeoff. Then you can change the angle so I can run the RPMs at a lower RPM setting, but the propeller is taking larger bites of air. Now, that's more of a cruise prop, right? I want to slow down my engine, I want to slow down my fuel consumption, but I don't want to slow down the airplane. And this allows you to do that. Most fixed prop airplanes use a combination prop. It's neither a climb prop or a cruise prop. It's somewhere in between, and you give up some performance in climb, and you give up some performance in cruise. Some people, my 172 had a climb prop on it, so it was real good at getting up and out, but it was slower than what it should have been. Okay, below these two, I have the alternate static port. So if I get icing on my static system, I can open it up to the atmosphere using that. If that fails, then of course you got to come up here and you got to break this glass, which I don't even have a tool to do it, but that's what they say you can do. Okay, coming back up the panel, exhaust gas temperature gauge, and that is controlled by a knob here. I can look at all 6 cylinders by flipping the knob. Then we have a carburetor temperature gauge. So inside the throat of the carburetor, this tells me what the temperature is in degrees Celsius. And if it gets into the yellow arc down here, I know that carburetor ice is possible. What you do then is you come over to this lever. This is the carburetor heat lever. And I can add a little bit of carb heat to get that needle up out of the yellow. Now that's only if I'm traveling through visible moisture, or if it's a very, very humid day. I've never had carb ice in a Piper. I've seen it in a Cessna, in a 152 that I was in, and they're famous for it. That 0200 it had. but I've never had it in a Piper. Doesn't mean you can't, just I've never experienced it. Okay, we come back up the panel. So this is my nav, what's called a CDI, course deviation indicator, and these two needles are tied into the #1 nav radio. So this does double duty. It's a GPS, and it's also a nav radio. It's got a nav and a comm radio built into it. And currently, of course, I'm on GPS, and I'm always on GPS, to be honest with you. I haven't flown a VOR in years, 3-4 years. I haven't flown a VOR. I've checked it. It's accurate, but I haven't flown it. So these needles indicate how left or right of course you are, and then when you're on a glide slope, or if I'm following an LPV approach, how low or high the glide slope is, if the glide slope is above or below me. So you want to fly to the needle is what it boils down to. If the needle is to the right, that means my plane needs to be to the right to center that needle back up. If the needle is to the left, my plane needs to be to the left of where it currently is to center the needle back up. If the needle is above me, that is very bad. It means I'm below the glide slope, and I need to slow my descent to let that needle come back down. If the needle is below me, that's still bad, but not as bad as if it's above. Then the glide slope is below me, and I need to increase my rate of descent, need to hustle down to it. Then you can set your course, and I won't get into radials and tracking a radial and identifying where a radial is. There's plenty of stuff online you can find about that. This is the same thing, only for the #2. I got a KX155 with a glide slope here, and this indicator, if this radial fails, this is my backup, or if I am shooting an ILS that uses a cross radial off a different VOR for the final approach fix. I know for the non-pilots that's a bunch of gibberish. It just tells me where I am in space. Like I said, since I got the 650, I haven't used any of them really, for VOR anyway. Now, manifold pressure gauge and tachometer. These two together tell me how much horsepower I'm making. Explaining a manifold pressure gauge. A manifold pressure gauge, a lot of people think it actually should be called a vacuum gauge, really, because it's telling me how choked or how open the carburetor is, or the butterfly is, how much air the engine's able to pull in. So right now it's at atmospheric pressure. Of course, the engine's not running. If I turn the engine on and I'm at idle, it's going to be down here somewhere in the 10, 8, 10. And then as you put the throttle in, the butterfly opens, the engine is able to suck more air in, and that's measuring how hard the engine's sucking, really, how much air it's pulling in. You combine that with your tachometer, and I have a digital tachometer I put in a couple annuals ago, and there are tables then, that's one of the things that is on my leg, strapped to my leg. The table tells me what combination tells me how much horsepower I'm making, which I can then set fuel burns by, so on and so forth. Now we come down here. This is the STEC 50 Autopilot, and I do have altitude hold, and it's literally on. That's into standby. Then you can turn the wings with this knob, push that one in, it holds altitude at whatever it is currently. Push this one in, it'll follow the nav. So whether I'm using GPS or I'm using the VOR, for example, the nav will follow that. Approach mode is very similar to nav mode, only it is for a much tighter tolerance. And you do that when you're coming down an ILS. Also, I use that when I'm flying GPS because it's just more accurate that way. Then you have the reverse button when you're shooting a backwards. It's shooting the back course on an ILS. There are certain approaches that use the same ILS, only they flip-flop it, and you come in the opposite side of the runway. Anyway, that's, once again, kind of out of this. Now, you turn it off with this button, or you can come over here, and I got my push-to-talk. This is the altitude engage, disengage, and this is the autopilot engage, disengage button. right? So you can hit my altitude here to hold it, or I can hit this button to hold it. I normally just reach over and do it in the panel. Okay, up here I have a gear alert system. So this plane has 2 gear alerts. If the manifold pressure drops below 12 inches and the landing gear is not down, I'll get an alarm. If the second system is if the second notch of flaps goes in and the landing gear is not down, I'll get this alarm will light up. And you'll hear this sometimes when I'm taking off with flaps and I go to put drop the flaps, I'll bump the second notch as I'm dropping them and it'll go off a little bit. Next to it is a fuel pump indicator. So when my electric fuel, there's 3 fuel pumps on the plane. One is driven by the engine, and I've got 2 electric fuel pumps as backup. When those 2 electric are on, that light comes on. And then this is the alternator fail light. So if my alternator fails, that light will come on and tell me that I'm now running on battery power. That is something else that I'm looking into. Once I get rid of the vacuum pump, the aircraft will operate strictly on electric, right? Everything is now electric. Now these 2 units have a 4-hour battery backup in them. I'm not too concerned about that. But the landing gear is electrically driven, and most of my navigation, all of my navigation equipment, other than the compass, is electrically driven. So I'm considering looking for some kind of backup power source, be it a second alternator, that if my alternator fails, I've got some kind of backup to it. I do have the battery, and if I shut down most of the electronics, turn off the autopilot, etc., I can probably stretch that battery for a decent time, but still having a secondary source is something that I want to look into. Okay, this is the audio panel. This is a Bluetooth audio panel. It's called a PMA 8000 BT by PS Engineering Incorporated. The reason I put this audio panel in is for the Bluetooth. A lot of people think, oh, you can listen to music, and you can, but when your IFR, the radio is going so much, you really can't hear the music anyway, and every time you talk or somebody else talks, it cuts it out. What I do like it for is calling for clearances. When I'm sitting at the end of the runway, ready for takeoff, and I need my IFR clearance in a non-towered field, there is an 800 number that you can call to get that. And having that Bluetooth hooked into your headset, you just dial the phone and get your clearance. It's the only reason I put the Bluetooth in. Okay, this is what I consider to be the nicest box in the airplane. It's what I spent the most money on, and it's worth every dollar. It's a Garmin GTN 650. They do make a 750, which is basically double in size. It's basically these 2 together here, and you have more screen space. The 650 does 90% of what the 750 does. It doesn't display charts. It doesn't display stuff like that. But I use the iPad as a backup, and unfortunately, there's not a lot of room behind this part of the panel, so I would have a hard time fitting a 750 in and keeping the transponder in. I'd have to do something different with that. Anyway, this has made IFR flying. I've talked about it before. This has made IFR flying just it's cheating. I mean, it is so much easier to fly IFR with a moving map, WASP GPS. It's day and night. It really is. So this is a Garmin GTN 650. It's got a moving map. I normally don't fly with the moving map. I got an iPad that has a better map on it. I do fly normally with this default navigation mode, where I have my ground track, my desired track, my cross track error, my distance to destination, my distance to the next waypoint, and my estimated time en route to the next waypoint. And then it's got your, what waypoints you're running, and it's got a CDI down here, which is the same as this, only displayed in a different manner. That's something else that when I get the G5 down here, it will have a glide slope, up-down needle, and a localizer needle on this unit that's tied into that 650. So that means I could replace this. I don't know if I will or won't. I got to talk to the avionics guys about that, on what I should be doing with that. KX155 is a Navcom radio. Pretty standard. You'll see a lot of these out there. Very popular radio, good radio. Unfortunately, they're no longer supported. Once the face dies, the radio dies. So at some point, I'm probably going to have to replace that. Then this is a GTX 345. This is what I did for my ADS-B in and out. That is due in 2020. For folks that don't, or for non-pilots, ADS-B is a ground-based system that supplements radar. It basically is the plane telling the ground, here's where I'm at, here's who I am, and here's how high I am, using a GPS source. Now, they also still have radar, of course, bouncing off the aircraft. And that requires a Mode C signal, and that'll be in place probably for decades to come, knowing the FAA and how slow they are. But that's all due in 2020, and this is the unit I chose. There's a lot of them out there. I think the L3 is really nice. The L3 gives you a traffic display built into the unit, which is kind of cool. I show traffic on the iPad, and traffic shows up on here. But having a dedicated traffic display, if I'm on the right page up here, having a dedicated traffic display, I think is a benefit. I like that idea, but it wasn't available when I did this, so I didn't know about it. Autopilot on, off, and test button. Primer. This primes the engine. We come back up here. This is my fuel flow indicator. So you might have seen me before I take off. I set how much gas is in the tanks, and this tells me how much gas is flowing per hour through the engine. And this will tell me how much gas is left in the tanks, and how, more importantly, how much time is left in the tanks. I really don't care how many gallons are left. I need to know how long I have left. So I want to be on the ground before this says I got an hour left in the tanks. Cylinder head temperature gauge. I am considering replacing these two with a modern engine monitor. That way I could monitor all 6 cylinder head temperatures and have the fuel flow, and that would help with leaning and some other things. And you can tell what's going on in the engine a little bit better. Okay, this is a Davtron. It gives me my outside air temperature in Fahrenheit, Celsius, the pressure altitude, the density altitude. Once again, for non-pilots, pressure altitude is barometric pressure, right? It tells you how high you are from a given plane. I don't know how else to explain it. It's 2992. Anyway, density altitude is pressure altitude corrected for temperature. Temperature is actually a huge component. And then a voltage meter, which is what it's showing right now. Tip tanks. So I got a left-right switch, tells me how much gas is in the tip tanks. Then this is some engine and fuel. So these are the main tanks, left and right. Fuel pressure, oil pressure, amps, and then oil temperature. And then that's down here. I got a glove box where I keep some cables and different things. Now on this side we have the cabin vents. Got left and right. Nose open the chin vents. You have the defroster, which, as you can see, gets very hot. It'll actually melt the window. And then cabin heat, which also actually gets really, really warm. Then I have a cigar lighter that I use plug my iPad and everything into. And that's about it. This is the flaps. Johnson bar, 3 notches, pulls the flaps up down or retracts them. Emergency gear handle extension. So when I put the gear up, when I tuck the gear into the wings, this rotates down and lays flat on the floor. If I have an issue and I can't, and my gear won't come down, or I lose electrical, I don't have enough battery power, I have to pull this plate up, and it just pops straight up. Inside there is a lever to release the transmission. There's an electric transmission under the floor. That lever releases the transmission, and the gear will fall a little bit out of the wheel well, and this will pop up. You then extend this handle. You slow to 100 miles an hour indicated, which is pretty slow in this plane. And it's a lever. The oldest known man-made tool, a lever. That's what it is. And there are bungee cords, and I'll do a video maybe on the gear to show you how all that works down there. There's bungee cords that'll help you pull those gear back what they call over center, and it'll lock them down. Then you go in and you land. The problem that people get into is if you don't do proper maintenance on the gear, they won't extend because something gets bound up, and then you really got an issue, and you'll end up just landing with the gear up, and that pretty much is it on the, for the plane, because the insurance companies will just write it off. It's not worth fixing them. You get additional venting. You got vents here, and in the back they got the same thing. Little doors on the outside open and let some air in. Vents here, eyeball vents. A lot of people ask me about this. That is actually a door handle off of, I think it's a Ford. Piper just used that door handle, and what this does is it sets the trim on the back. And it's just, if I want to trim it nose up, I rotate it this way. If I want to trim it nose down, I rotate it this way, and just like cranking on a window. And that is it's a door or a window crank from an old Ford. Then you got some lights and the speaker and everything up here. I'll show you. I'll walk to the back real quick and show you the little tab on the tail that adjusts. But anyway, that's pretty much it. That is the panel. Nothing too exciting. I don't have like a G1000 in it or nothing like that, nor would I put one in it, to be honest with you. You have to be realistic when it comes to resaleability, right? So someday when I'm 70, 80, 90 years old and I need to sell it, I don't want to have too much into it that I can't sell it. I did forget to mention this. This is the rudder trim. So you can adjust it right or left, and that takes some pressure off the rudder. Through springs, it takes some pressure off the rudder pedals. So let me walk back and I'll show you what this is adjusting. Because I have to adjust that every flight. Just trim the pressure off the yoke. And anyway, so let's walk back there real quick. Step down here. So that trim adjustment adjusts this. And as you're flying for non-pilots, once again, pilots are going to be like, duh. For non-pilots, though, as the air flows over the stabilator, and this is a stabilator, so the whole unit moves. You see how that wing, that little one on the back, flexes? And what that does is it takes and it flies. This is a wing. This is a wing. It's just a wing that's inverted, right? So the engine up front, very, very heavy, forward of the center of gravity, forward of the center of lift. All the airplane of a tail does is it flies down through the air. It creates lift on the top, flying the tail down, and the long tail, or the long fuselage, acts as a lever to lift the nose up, right? So, which is, I know, sounds like a lot, but basically it's a wing that's upside down. It's flying down to hold. It flies the tail down to hold the nose up. It's the simplest way to explain it. And all that trim thing does is it sets the angle at which that is doing it. Now, here's what it does, some additional things. So that tail also adjusts the angle of attack on the wing, right? If I fly the tail down more, the angle of attack comes up on the wing. And if I want to hold that angle of attack up or down or in the middle for straight and level flight, I can use that crank. I push forward with the yoke or pull back on the yoke till I get the angle I want. That'll settle at a specific airspeed, and then I can trim it to hold it. That's the easiest way to explain it. Easiest way to explain it. That's about it. So there you have it. That's my video here for this week. I try to do one every couple, 2-3 weeks here. If anybody's got any questions, please put them in the comments below, and I'll be happy to answer them. That's it. Hope everybody has a good week. Talk to you later. Bye.